Hi class, how are you today? Well, that's the root of the problem. You have zero solutions to my question every time. Alright, well the learning target for today is to be able to solve quadratic equations by graphing. For the scale, you're a 3 if you can solve quadratic equations by graphing. You're a 2 if you can graph quadratic functions, like we've been doing previously. You're a 1 if you can solve quadratic equations if given the graph, so if you already have the graph to look at, then you can solve it. And 0, you cannot solve quadratic equations if given the graph. Let's get started. Alright, so you've learned how to graph quadratic equations. Now, a very big part of what we're going to be dealing with coming up now is solving quadratic equations. And the first method we're going to use to solve quadratic equations is what we were just using, by graphing quadratic functions. So if we can graph a function, it will help us to solve the equation. So if you remember from when we are identifying the different parts of the graphs, one part were the x-intercepts, which I also called solutions, roots, and zeros. So we're going to say solutions, but I might interchange these. But the solutions are the x-intercepts. It's when the function crosses the x-axis. This is what the solution to the quadratic equation will be. Alright, so this first one here, notice that it intersects the x-axis in two places. This will probably have most commonly. We'll have two answers, two solutions. And you'll see that it crosses at -2 and 2. So the solutions are -2 and 2. So, as I said, there are two solutions, and the graph crosses the x-axis twice. That is one possible type of solutions that we could have. The other type is, notice that the vertex is touching the x-axis. So it only actually hits the x-axis once. So there's only one solution. A graph only crosses the x-axis once. And then here, on this third one, notice it doesn't cross the x-axis at all. So here we say there is no real solution. And I'll get into what that means in a later lesson. So for right now, we can just say no solution. But in reality, it's no real solution. And the graph will never cross the x-axis. Because again, the minimum is at 2, so it'll never go below 2. So it'll never actually hit the x-axis. Alright, now we're actually going to find some solutions. And we kind of just went over it. But now we're specifically going to write it down. So it says here, use the related graph of each equation to determine its solutions. So we have the graph here, and it intersects the x-axis at 5 and at -2. So that means that our solutions are x equals 5 and x equals -2. And this is the equation for this graph, x squared minus 3x minus 10 equals 0. So we're going to have this equals 0 a lot. And what the equals 0 talks about is just this whole expression, the function, if you will, is equal to 0. And we want to know what is x when that equals 0. And when the y equals 0 is when it crosses the x-axis. So x squared minus 3x minus 10 equals 0. Then we graph the function y equals x squared minus 3x minus 10. And we get it here. And we get that our answers are 5 and -2, our solutions. And on number 2, we have negative x squared minus 8x minus 16 equals 0. And notice this one actually opens downward. That's because there's a negative in front of the x squared. If it's positive, it opens upward. If it's negative, it opens downward. And again, it equals 0, so we graph it, and it's right on the x-axis this time. So if the origin's right here, we count 1, 2, 3, 4. It's x equals -4. And there's only one solution, just like we said before, because the vertex touches the x-axis. So when it only touches it, there's only one answer. Alright, now that we've looked at some pre-made graphs and figured out the solutions from those, now we're going to graph on our own and then find the solutions. So, we've been graphing before, so let's do what we've been doing. First, we start by finding the axis of symmetry, which, as you know, is x equals -b over 2a. So that will give us -4 over 2 times 1. So that'll give us 4 over 2, which is 2. So the axis of symmetry is x equals 2. So then, to find the y-coordinate of the vertex, because that's the x-coordinate of the vertex, we plug it in, and we say y equals 2 squared minus 4 times 2 plus 3. 2 squared is 4. 4 times 2 is 8, plus 3. So that will give us -1. So our vertex is the point 2, -1. So we can graph that point, 2, -1. So now I think it's helpful to make what's called a t-table. And you may have used these when graphing linear equations, and they're very helpful there and they're very helpful here. So we have our x and our y. And so our vertex, let's put somewhere in the middle. So we have x is 2, y is -1. And so we put it in the middle because the vertex is the middle of the graph. It's where it changes, it's the symmetrical point from either side. It is the middle of the graph. So let's put it in the middle. And let's fill in some x-coordinates. We don't have to find out all of them, just some of them. Alright, as we've done before, the easiest after this is the y-intercept. Which is always when x is 0, and the y is the number by itself. So 3. So we have 0, 3. And we can plot that point. 0, 1, 2, 3. And it will be, it's 2 away from the axis of symmetry, so it'll be 2 on the other side. So we have that point there. And when we graph, we usually want a point in between. But we're also specifically looking for a point that will intersect with the y-axis. So we've got our vertex is below the y-axis, and our y-intercept is above the y-axis. So that means that our next point very well could and should intercept with the x-axis. So let's see if we can find that out. So the next thing we would try is 1. So we say y equals 1 squared minus 4 times 1 plus 3, which is 1 minus 4 plus 3, which equals 0. So that gives us our point of 1, 0. And we can graph that, and its reflection, 1, 0, and 3, 0. And yes, I had forgotten to plug in this one over here. That was 4, 3. So this kind of helps us look. You don't have to use the t-table. It's just another way to see what you're graphing. And so when the y is 0, that is the solution. So when we go to graph this, we see that the graph intersects the x-axis when x equals 1 and also 3. So our answers, our solutions, roots, zeros, are 1 or 3. So x equals 1 or 3. And we do need both answers. Alright, let's do one more example. So in this one, notice it doesn't equal 0. It's x squared plus 2x equals 8. In order to graph it, we need it to equal 0. So there's one step we're going to have to do first. So we want it to equal 0, so we're going to subtract 8 from both sides. And that will leave us with x squared, and a lot of people will try to combine these two, 2x minus 8. One's an x, one's a constant, a number by itself. You can't combine these two. So it's just going to be x squared plus 2x minus 8 equals 0. And remember, we do need the equals 0. Some people think the equal sign just disappears when the right side disappears. It becomes equals 0. So that's what we need. Then we do what we did before, find the axis of symmetry. So we have x equals negative b over 2a. So negative 2 over 2 times 1. So negative 2 over 2, which is negative 1. Then we plug it in. Y equals negative 1 squared plus 2 times negative 1 minus 8. And that will give you 1 minus 2 minus 8. So that will give you negative 9. So our vertex is the point negative 1, negative 9. And I've already set up my t-table over here. So I have negative 1, negative 9. That's my vertex. Center of the t-table, center of the graph. Next, y-intercept. Y-intercept is when x is 0. And so negative 8 is the number by itself. So 0, negative 8. And its reflection over the axis of symmetry. So we have 0, negative 8. And negative 2, negative 8. Now notice our x-intercept is going to be much farther away than it was previously. Before it was between the 2 points we had. Now it's a bit farther away. I'm just going to keep going in order and graphing the points. But you can jump to the one you think it is and see if it works. But I'm just going to keep going. to kind of show you how quickly it goes there. So our next point, we've got -1, we've got 0, let's use 1. So to get that, 1, and then plug it in, so we have 1 squared plus 2 times 1 minus 8, so 1 plus 2 minus 8 is going to be -5. So 1, 2, 3, 4, 5. Then we go to 2. 2 squared plus 2 times 2 minus 8 equals 4 plus 4 minus 8 equals 0. So this point is 2, 0. So now we have our new point, 2, 0. And its reflection, which is 1, 2, 3 away from the axis of symmetry, so 1, 2, 3 on the other side, will give us -4, 0. So we can put that into our t-table, and that's when y equals 0. Forgot to put the xy here, sorry about that. But that's when y equals 0. So those x values are our solutions. So we have x equals 2 or -4. Alright, now time for the sponge activity. Solve the equation by graphing. So just like we did in the video, find the vertex, find the y-intercept, find other points until you find the x-intercepts. And those will be your solutions. So I need the x-coordinates for those, and those are your solutions. So you'll have x equals something. There may be 1, there may be 2. Technically there may be none. Alright, that's it for this lesson. Once again, please make sure to take notes on the entire lesson. Take pictures of everything, including the sponge activity that you need to attempt. Submit it all to Google Classroom, and have a good night.